The building envelope of the house is it's the shell of the house. It's the key thing that keeps the inside and the outside, and keeps the weather away from you and keeps the house warm. The average Auckland house uses about 30% of the energy just to heat the house. So the building envelope is really important in that that's what allows us to avoid having to heat the house, which is a 30% saving, which makes it much easier to reach the zero energy house goal. So by designing the building envelope to naturally keep the whole house warm, every single room can be warm. You're not having to heat one room and live in that room, which is often what you tend to do in a cold house. So naturally you're in a healthy, warm environment right around the house. Obviously by avoiding the need to heat, we avoid the need to buy the electricity or the firewood or whatever you might use to heat the house. So we don't have to pay for that, which is brilliant. So when the prices of that keep going up over time, we're not exposed to those changes. The other benefit, of course, is that it means the solar system can be smaller, because to be zero energy we need to generate all the energy we use over the course of the year, but we don't have to generate that 30%, so the system can be 30% smaller.
Passive solar gain is about designing your house around the sun, so putting more glazing on the north side than on the south. It's all about retaining that heat as well, so having a highly insulated building envelope to trap that heat inside. So when we were looking at the layout of the zero energy house, we worked out what rooms we were going to spend most of our time in. There's typical living areas like the lounge and the bedrooms, and we located those rooms on the north side of the building to make sure they get the most amount of solar gain through the day. So another part of passive solar design is also making sure that in the summertime, when you've got lots of sunshine around, designing for shading of your building. It can overheat in the summer with too much sun coming in through the windows. So on our north side we've got an overhang which shades during the summer but lets sun in during the winter. The sun's free heating, so designing for passive solar gain is the most cost-effective way of keeping your house warm.
One of the key features that helps us achieve the zero energy goal is the framing system. So we've just tried to evolve the current framing systems that's used in houses a little bit further to give us a better thermal efficiency and to make it easier on site. So we've got, rather than just a stud with nogs in between, which you obviously aren't here, we've moved that nog and put it as a batten on the inside of the building. So we get one layer of insulation through here where the studs are, and another layer of insulation where the battens are, and then the jib goes on the outside of that batten. So that means that most parts of the wall there's insulation right through, and the only place where there's timber that goes from the inside to the outside is where the two cross. But normally there would be, where there's nogs, there's also timber going right through the whole building. So because there's insulation behind this stud as well, it's very well insulated and you get very high thermal performance. The thermal performance of this wall is over 50% more than is required by the building code, and by doing that we can do it for very little cost because we're not using any more timber. We've got a little bit more insulation, but the outcome is that we don't need to heat the house because it's very well insulated.
We used Ortex Green Stuff, which is a polyester fibre bat. It retains its thermal performance over its lifetime, and it comes with a 50-year guarantee. It's safer and easier to install. It's also made out of a minimum of 45% recycled bottles, and it's also endorsed by the Asthma Foundation. We're using a concrete slab for thermal mass at ground floor level. To be able to retain the heat in that concrete slab, we've got insulation around the edge of the slab. Before we lined the house, we had a look at the building envelope using a thermal imaging camera. That kind of camera can be used to track where you might have any heat leaks within your building, so it might be where you have gaps in the insulation. We've got a strip of green roof that sits in between our main part of the house and also the garage. It's about 8 square metres and it covers the entrance hallway. That green roof provides thermal mass in the roof of the space, which means that the temperature in that space should be regulated over the year. It's important for us to protect the timber framing that goes under the green roof. We've done this using EnviroClad, which is a membrane available from Viking Roof Spec. We've chosen EnviroClad because of its performance. It's durable, it's heat welded, and it's recyclable at the end of its life.
The windows are really important because their thermal performance is much less than a wall, so it's really important to have really good windows because you lose a lot of heat out of your windows. We chose wooden joinery for a couple of reasons. One, because we actually really like the look of it, it's just nice. And the second part is its thermal performance. It can perform better than aluminium because it's got a better thermal resistance, so it doesn't get as cold on the inside, which also helps because you don't get condensation forming on the joinery. The windows aren't like your normal window that opens out and it just hinges one way. The window opens in, so it hinges in, but once you've closed it you can open it again but tilt it in instead. So by tilting it in you have about 100 mil at the top, which just allows air to flow through, and you can leave it open during the day. It's quite sheltered from the rain, it's secure so people can't break in, and it's really important for the zero energy house because it allows us to ventilate the house over the course of the day and keep it cool and keep it dry. Windows are made up of two parts, the window joinery, the frame, and the glazing. The glazing we've chosen is double glazed, low-E coated, and filled with argon. So what that means is it's really good at keeping the heat in the building, and also keeping some of the heat out in the summer. The glazing we utilises a coating called the ClimaGuard N70. It's a 24mm double glazed unit, and it has a low emissivity, so it reduces the amount of heat that's transferred from that surface. And one of the benefits of that is it's got a lower haze and reflectivity. You often get that on other low-E coatings, but they don't look very good. It distorts your view through a window. The ClimaGuard N70 low-E coating has much lower haze and reflectivity. Another way you can lose heat through a building is through air infiltration. So air, on a windy day you can feel those breezes through the windows, for example. That transfers a lot of heat out of the building and also moisture into the building. So we've paid a lot of attention during the build process to seal up all those holes. Some examples would be, taping the building wrap, sealing around the windows. The windows themselves have got rubber seals to seal the windows. So it just means that we can control the ventilation. So if we want ventilation, we can open the window, but if we want to slow down or stop the ventilation, we can close the window and it doesn't leak into the house.